Hello, we're back with the second part of the 2013 PAT. So we've moved on to the physics questions here. This time they were doing 5 2-mark multiple choice questions. So this should be quite a short video. We're starting here with an ideal transformer of 100 turns on a primary coil connected to an alternating supply 100 volts 2.4 amps. How many turns are required on the secondary coil to double the voltage, double the current, I should say. So yeah, voltage is proportional to turns and current is inversely proportional to turns. So if we want to double the current, we need to halve the turns, which means we're going from 100 down to 50. Straightforward enough, providing you can have an understanding of how transformers work. Right, radioactive sample contains two different isotopes, A and B. A has a half-life of 3 days, B of 6 days. Initially in the sample, there are twice as many A's to B's, right? So a ratio of A to B is 2 to 1. At what time will this ratio be reversed? Right, well, let's go in blocks of 6 days because I can't believe they're going to give us part of a half-life of B. So after 6 days, our A would have halved twice. So it would go down to 1 and then a half. B would have halved once. So we're going to need another 6 days, aren't we? Because after 6 more days, A would have gone down 2 more half-lives to an eighth. B would have halved to a quarter. So we need 12 days. Much quicker just going through the options than it is going through decay equations, I would say, for this one. Right, resistor network. Right, these are always a bit of a gimme. Overall resistance between A and B. Right, so that's going to be a half there. That's going to be 2/3 there. So we're going to have 3/2 plus 2 is 7/2, and then inverse of that. So that gives us 2/7. Yeah, that really was straightforward. You should be pretty quick on these and not have to keep on going to the formula all the time for working out these. Even when you've got this bottom bit here, you've got 1.5 and then you're doing the reciprocal of it. I mean, it's just just be able to do these quicker because these are so simple and you're doing them over and over again. So just think about what's actually happening in the formula and you'll be just working these out in no time. 2 satellites are in orbit around the Earth. The first is in geostationary orbit. The second satellite orbits with radius half of the first. What's the period? Right, so Kepler's third law, which is weirdly popular in PAT papers. So we've got this. So we can actually just divide these things through then. So we could, because we must have the same ratio of them. So let's do the new one. So that's T squared over the old one, which would be 24 squared. So that's just doing now ratio of orbital times. So we're going to want to have r cubed, and this is at half the radius. So it's going to be r cubed divided by 8 divided by r cubed. So our t squared is going to be 24 squared over 8. So that's 3 lots of 24, which is 72. T is the square root of 72, which is 6√2, because that halves into 36. 6√2 is going to be about 8.5, give or take. Right, so there we go, B. That was fine. Again, taking these ratios here, it's quicker than we'll square root and then we'll cube and we'll cube root and all this sort of stuff. It just sort of builds it all in. Similarly, when you're doing these fractions, don't square the 24 when you can divide by the 8 first. Always look to make numbers smaller rather than bigger. Right, 15. So this is the last one of these 5. You are in a desert and discover a radio mast. 100 meters from the mast, you measure 20 watts of power from the transmitter. You require a minimum power level of 1 milliwatt. How far away from the tower can you go? Right, so we've got P is proportional to 1 over r squared. It's dropping off because we've got this expanding, ever expanding area. The power is how much are we getting through a particular bit of the area at the distance that we are away from the transmitter. So obviously the area of this ever expanding sphere is proportional to r squared, so the power's dropping off with a 1 over r squared. So that means for what we start with, we can get our constant of proportionality. So 20 is equal to k over 100 squared. So we got k is 2 times 10 to the 1, 2, 3, 4, 5. So now we can put this in again, and we want to say that now we got 10 to the minus 3 is equal 2 times 10 to the 5 divided by this d squared. So d squared is going to be the square root of 2 times 10 to the 8. So root 2 times 10 to the 4, which is, oh, here we go. They've just changed C into kilometers because this was in meters I was working with here, because this was in meters. So they've changed that to a 10 root 2 and turned it into kilometers. So let's just check that is the last one. Yeah, so that was 5 really swift questions. Nice questions, but very manageable.